All right, my name is Nate Richardson, and I'm going to be talking about the flood of Noah. So let's talk about this. This is about the geology of the flood of Noah. This is from Universal Model. So, proof of Noah's worldwide flood, geology of the Universal Model. My name is Nate Richardson. I been have the privilege of working with Dean Sessions with his awesome New Millennial Science, and this is from Volume 1, The Earth System. I put this together on it's got a bunch of pictures from the book which you'll really enjoy, and a bunch of neat stuff that we'll talk about. I've tried to summarize things. I'm going to try to keep this reasonably short, um, and let's go. So right on the front here you can surmise that the present condition of the earth cannot be assumed to be the only normal one in history. Okay, we're going to talk about how catastrophe theory rather than uniform or uniformitarian theory is the correct theory. There was the Plutonists who thought that the earth was made out of basically a fireball, and the Neptunists who said, yeah, it's more like a water ball. And we went into a lot of detail on that in one of my prior recordings, which focused specifically on establishing that the earth was made out of water and ice in its core, and that it has a lot lighter density than we have supposed. So if you haven't studied that stuff, that will help, but you're welcome to jump into this too. Like this, you don't have to have that background stuff to be good at this. All right, so hydro fountains viewed from space. We're going to talk about mountain liquefaction. We're going to talk about catastrophic burial of flood for dinosaur death, the flood of Noah, and young Earth, etc. Okay, so this is a little recap of what my last thing was on, the water god versus the fire god, and about how it really is a big thing for atheistic science when we've got all the magma interior, which leads to the radiometric dating theory, which leads to the old earth, which leads to evolution, which leads to God's totally out of the picture. So the young earth uh, model is much easier to comprehend if we have the water in the middle, and it gives us plenty of resources for the floodwaters too, and that's what we're going to be focusing on today. So, okay, so something that I like to point out is that magma is like the new caloric. Humphrey Davy disproved that there's this magical substance called caloric by using friction. He rubbed these ice blocks together, made the demonstrated heat, and the same thing's happening over. We have this magical stuff called magma that nobody's seen. Obviously, there's surface lava, but I'm talking about ocean of magma deep underneath the crust, and no one's seen it, but we can demonstrate by friction in Earth's crust that you don't need it. So it's really kind of funny. This is also similar to Lavoisier disproving phlogiston. So the flood of Noah covered the whole earth. So think of these mountains being covered with water. And Genesis 7:18 through 24 points out that all the high hills were covered under the whole earth. Okay, the waters did prevail, the mountains were covered. All the flesh died that moved upon the earth. Every living substance was destroyed, which was upon the face of the ground. And the waters prevailed on the earth. Okay, so how much water, how deep, etc. Mauna Kea is the tallest mountain from the base to peak, more than 33,000 feet, about 5.5 miles. So now how much pressure is going to be existing with that deep of water? If you were at the bottom of 5 miles of water, that's an extreme amount of pressure, and it's actually the just right amount of pressure to turn an organic substance like a tree or a bone into a fossil. Fossils don't just happen every day. And we also went we're not going to focus on fossil formation because that's something we covered in a prior lecture too. But there's a whole chapter on fossils in the book. So where did the floodwater come from? It's a big question. So it can't just be rain because there's not enough water in the atmosphere for that. And the Bible says the fountains of the great deep were broken up in Genesis 7:11. Now, I'm going to say here that I don't know much about the firmament that it talks about in the scripture. I don't know if that's just the water in the atmosphere or if there's something beyond that that supplied additional water back then that's no longer there. But this is a science textbook, and we're focusing on what we can prove more than what we can philosophize about. So we're just focusing on the evidence that we have today, and there's plenty of evidence that there's plenty of water from inside the earth to cover the continents with water. We're going to talk about how the continents basically got brought down in deeper to the earth and the water came up out. And then when the earth returned to its normal spin rate, the continents came back out and spread apart. But anyway, let me touch on one or two more things here. So scientists will point out that if all the water vapor in the atmosphere abruptly fell as rain, over the 3,100 cubic miles of water would only cover the earth with barely an inch. So obviously that's not enough. But notice how this Genesis 7:11 says, the same day all the fountains of the great deep were broken up. All the fountains on the same day. So this is on one day, a lot's going down here. Okay, this is a depiction in the upper right on hydro fountains viewed from space. Along these fault lines, when they break, the pressurized water comes bursting out. Another thing that it's commonly taught that the ocean water is 95% of Earth's water, but what we have discussed prior is that actually beneath the continent crust and beneath even the ocean crust is a massive amount of water, probably more like 99% of water is below the oceanic crust. So we're talking, this is truly a hydroplanet. And there's many, something we talked about earlier, there's many hydro moons, hydro planets that we know of. And scientists hesitate to admit anything related to a hydroplanet because it makes it pretty obvious that the flood could have happened and not just some local flood. It's pretty popular these days, and I know Hugh Nibley fell into this trap too, where they're talking about, oh, the flood was a local flood. It was from his perspective and so forth. But we're going to talk about how there was 5 miles of water covering the earth, covering the mountains. This was big time, and it laid down miles deep of sediment. When you go out on a walk today, you're walking on sediment that was put down in the flood. So we're going to talk about this, and we're going to talk about Earth as a geode. We're not saying the Earth is hollow. We're saying there's rocks, liquid, and ice inside the Earth, okay? And it's basically like a geode. I mean, how hard is that to believe and understand? Because geodes are this awesome thing that we have in nature, and we need to zoom out, and see God's hands making these awesome things. And this is all, stuff that is hit on a lot more in the lecture that I did called Water versus Fire, where it talks about the hydroplanet versus the magma planet. So now that we're kind of up to speed, let's get on to more flood stuff. So I'm going to explain some basic mechanics of the flood in a little more detail in a minute, but first let's just take some preliminary evidence of what is that doing up there. Here we've got all kinds of things on mountaintops that are marine fossils, okay, and pillow lava, which is only formed underwater, which is on tall slopes of Hawaii, and you've got seashells on Mount Everest, seashells on the Himalayas, and in the Alps, and all over this place. And let's point out here that when you get one of those globes for your classroom, those 1 foot diameter globes, sometimes they'll have the bumpiness on them for the mountains. On a true scale Earth, you would not feel the bumpiness. That's how big the Earth is and how small the mountains are in comparison. So really, when we're talking about baptizing the Earth by immersion completely underwater during the flood, we're not making that big of a stretch. It's really not that hard to cover the Earth completely in water. But of course, scientists, man, that doesn't even cross their mind these days. But like I was saying, there was the Neptunists versus the Plutonists back in the day. Up to a couple hundred years ago, it was common knowledge that there was, a worldwide flood, and that the Earth, as it says in the scriptures, it was water in the beginning, and went from there. And I'm guessing some seed crystals were brought here. We brought the gods brought animals, and they showed up to start the human population. but I'm guessing they also brought seed crystals to help create the Earth. And then you've got a supersaturated precipitation that goes on a big scale. But anyway, so yeah, we talked about this. Oh, another thing that we like to point out is that if you were to shrink the Earth down to a basketball size, the crust would be about as thick as a sheet of paper. So again, covering the mountains is not a huge deal. You'll see blue quotes throughout this. Those are from the academic journals and whatnot. Those are all throughout the book. Universal Model is a pretty easy book to read because they don't just put little snips of the quotes in, they put the whole quote in, and it's in blue, so that's pretty awesome. They're not just saying, oh, well, some journal says this, go look it up. It's like, no, we're going to actually quote the thing, so it's really great. Let's move on from here. So mountains aren't going up. They were covered in deep water. Again, we're going to get into the mechanics of the 5 miles of water and whatnot. And we talked about that a little bit last time. But we don't have any evidence that mountains are going up. So you can't, this theory of gradual uplift doesn't work. That's the main theory right now, is that the mountains over slow time, long, slow time, plates coming together and they come up, and it doesn't work because we've got maps of horizontal plate movement but not of vertical plate movement. So, you know, where's the map of vertical plate movement? We just don't have it. And if we have GPS satellites measuring the height of Everest, it never moves up and down. It's moving a little bit horizontally but not vertically at all. I guess I'll in the beginning here I forgot to say a little bit of my background. I've been a science teacher for about 3 years, and um, I really enjoy looking into this stuff, and and that's what I'm still doing is teaching, and it's been a great experience. And Universal Model Millennial Science has been extremely helpful to help me discern between truth and error, and it really makes science come alive. And I also just want to say, I think a really important thing for our kids is that they learn science that is true. And guess what? The Bible is true. And true science is going to be in alignment with the true Bible. And so it's true science shows about a 6,000 years ago since the first humans, and it shows a young Earth. The Earth was created in 6 days. 7 days, and there's several scriptures that say God's days are 1,000 years, so maybe 7,000 year creation. Either way, there's also the flood of Noah that happened about 4,500 years ago, and we're going to get into more evidences for that. But I just wanted to say, when you're teaching science from an atheistic perspective and you're not tying any of this into religion and proof of God and proof of God's interaction with us, then science can be really boring. So I feel bad for kids who don't have the opportunity to go to a private school and learn. My hands are tied in my teaching of a lot of what I do. And I think it's a very small, group of kids, maybe some homeschool kids or some private schools somewhere. And of course, at BYU, they teach evolution, and they don't bat an eye to offer anything else, which is really tragic because Brigham Young wanted that school to teach against Darwinism. Anyway, so that's a little about my views and who I am, and we'll get back to some more studying now. The idea of subduction is problematic as well. You can have obviously plates collide, but the idea that they need to sink down into the mantle to be melted by magma and come up as volcanoes is not what goes on. We talked about earlier how friction between the collision can generate enough heat. We have friction welding where you can melt two metals basically in a fraction of a second, and you're doing just fine. You don't need to tap into some unseen magma to make all this work. It's like Lavoisier said. He basically said, nobody's seen it, and we don't need it to explain nature, so in all likelihood it doesn't exist. But that's, again, a whole nother ballgame. So yeah, we have about the 2.4 inches a year of horizontal movement of Everest, but never have we seen horizontal movement. So the mountains just aren't going up over time like they're saying they are. And when you go, oh, wait millions of years, that's magical fairy tale. That's not science. Okay, we can't wait millions of years. No one has waited millions of years. Okay, science is about what we can actually see and do. So if you want to go out and philosophize, that's one thing. But if you want to do science, don't be throwing around all this millions of years, especially when your radiometric dating doesn't hold water. So they'll say uplift occurred over relatively short and distinct time. So now we're familiar with mountains being made as an initial part of the creation of the earth, but during the flood, did some mountains rise up a little taller? Like, did some go up? Did some go down? I'm sure. Yeah, and we're going to even talk about proofs of that. But generally speaking, the mountain ranges, they're not just from, Pangea getting broken up and all this. We're gonna talk about how the mountains were covered in deep water. Okay. All right. So the scientists will say there's this period of little to no significant uplift, deviation from uniformitarianism. So what triggered this? And they say, we don't know. The abandonment of naive mountain building hypothesis might lead to further realistic explanations. So like, we don't know how the mountains formed. Yeah, of course they don't. And they say the real problem with subduction is it can do everything. It can account for uplift, subsidence, compression, tension. There's too many degrees of freedom, and it can account for opposite effects and is not testable. So that doesn't work. Now what we're going to talk about is some mechanics of the flood, how a very strong theory that's promoted in the universal model is that a certain comet did a near flyby to the Earth, and that threw things off with the spin of the Earth just enough to where the rotation rate slowly increased and a couple things happened. So, and it caused the breaking of the plates and the sinking of the plates into the water. We're going to talk about that. First, a little more evidence of these oceans covering the mountains. These are the Dolomites of Italy. They have starfish fossils. They have folded layers. I'm guessing that these folded layers were they weren't solidified at the time, and that it's not a gradual bending, but it was a bending in the time that it was created, due to it being not hardened yet. Dolomite is a limestone from the ocean, so why do we have this limestone from the ocean on this mountaintop? So we're going to look at evidence after evidence how this place and that place and this place and that place, where they're like, oh yeah, there must have been a ton of water here. Who knew? And it's like, yeah, who knew? Not like the Bible said anything about that. So there's no evidence of the mountains gradually raising, so they were covered in water. So here's where we'll get on to a little bit of the mechanics. So here's your comet. It passes by the Earth, and you've got the centrifugal force and the gravitational force. Those are two forces in equilibrium. Now, if you're spinning one way and your comet flies by right the other way, it could maybe slow down the spin just enough to where major things happen. Okay? So it slows the Earth's rate temporarily to a minor scale. This makes the Pangaea continent crack because the spin is now slowed. And whoa, boys, slow down and pull the brakes on the train. And so Pangaea continent cracks into 7 or more pieces. And also, isn't that kind of interesting when you think of the 7 dispensations? You think of the 7 archangels. You think of the 7, wounds of the crucifixion. And something significant I would propose about the continents getting broken up from one, and of the prophecy of them coming back together. So now, how could that happen? Well, maybe the rotation rate will get slowed once again, and they'll fuse back together. I don't know, but that's a best darn theory I've ever heard for explaining how that could happen. Um, and you know, God's at the helm, and we're getting little insights of how what God's doing is scientific. God is not a magician. What he does is calculated, and he's a super genius. So, and he's very involved in our lives, and nature responds to how we act, how we're acting, sin or faith. So, when the crust collapse, the continents submerge. Okay, why are they submerging? Okay, now this is really important. Look at this swings over here. I don't know if y'all have been to that ride at Lagoon, and I'm sure it's other places. Yeah, but anyway, the ride turns on, and the swings, as they go further out, they also get further apart from each other, and then they go around and around. And this is like what happened to the continents. Okay, so um, when the rotation of the Earth slowed, this caused the continents to sink down because there's less centrifugal force. Think of the swinging the bucket over your head with water in it. Okay, you slow it down and it comes back in towards the center. So we talked about how the Earth is primarily made of water. So guess what happens when the continents that are floating on that water, remember scientists admit that the continents are floating on something, they just think it's magma, but it's really a slurry of water and rock, tons of aquifers, massive amounts of water chambers. These continents, they're snapped apart from being one, and then they're going down, okay, because there's less centrifugal force. And guess what? When they go down, the water comes up, and all of a sudden your whole Earth is buried in water, okay? And then eventually, and while it's buried in water, it's there's a lot of earthquake going on with the crust, frictional rubbing that's making the heat, and you've got, you know, 13.4 thousand psi of water pressure, okay, and 750 degrees, you know, Fahrenheit heat. This is the condition for fossilization. We've talked about this, but there's no other time. Fossils aren't being made right now. This is it, okay. And then eventually, you know, the comet's out of the picture. The Earth returns to its prior spin rate, and that's another interesting question of what keeps the Earth spinning. As you know, why does the Earth not stop spinning, and why does it not stop revolving around the sun? And that's, let me tell you, there's more to it than just inertia and gravity. There's God is keeping it going. Let's just leave it at that for now. But anyway, it returns to its normal spin rate, and then guess what happens? The rides turn back on, the swings, they go apart from each other and up. They're coming up out of the water and apart from each other. Because remember, the continents are no longer one piece now. It's going apart. Okay? So, we're going to have to move on, but this is very essential concepts right here. Okay, this is William Whiston in the 1600s. He was a scientist who was ridiculed for suggesting a comet triggered the flood of Noah. And you know what I like to point out is that in the scripture it says that in the day, as in the days of Noah, so will it be at the coming of the Son of Man, right? So when Jesus comes, it's going to be similar conditions as the flood of Noah. And guess what the book of Revelation talks about? Yeah, a big comet that messes with us big time. And so I think that there's a scriptural case for a comet being involved at the flood and a comet being involved at the apocalypse. So the baptism by water and the baptism by fire. So think of this paperclip floating on the water here, and you know, the surface tension. And a question that people ask is, okay, if the Earth was covered in water, where'd all the water go? And the answer is, okay, it's like the continents got dunked in the water and back out. It was a baptism, and that's very special. It was a baptism. They got dunked, and now they're back out. It's like the water's still here. Okay. Wow. Okay, let's keep going here. So this is a depiction of when you've got the that crust moving, it slides down on a fault, and when you slide, boy, that friction is going to heat things right up. Billions of pounds of rock, you're going to liquefy easily. We have way more pressure than we need to liquefy rock from friction. Okay, we don't need magma from a mysterious, you know, hellish ocean of supposed magma under the earth. Right? The earth's not hell. Anyway, so here it comes. And yeah, you're getting, these volcanic activities on the surface, which the main thing that's coming out of them is water vapor and slurries of rock and mud. And what do you need for mud? Well, you need water, a lot of it. And we'll get more into this. So this is a big example that there are bodies in the solar system that are filled with water. This is a mass ejection of water that we saw on a moon of Saturn called Enceladus. And it has a density of just above water, meaning it's mostly water. And they're really hesitant to allow this for our Earth, though. Okay, so scientists are acknowledging that there was major flooding. They say North America was under several hundred feet higher of water than we see today. And, if it was that way in America, it probably darn well could have been everywhere else too. But they're just finding evidence. They don't know what to look for a lot of the time, so that's why they're taking a long time to figure this out. But Dean has definitely made some very monumental and inspired breakthroughs in all of this. So the fundamental conception that all geologists possess in the past are not fundamentally different from those which are still active at present today. The doctrine of uniformity, the limited doctrine of uniformity, and do not suggest a complete admission of possible existence in the past geological records of sets of conditions vastly and fundamentally different from those prevailing at the present time. So they're saying, yeah, I guess things weren't always eking along inch by inch over deep time. There could have well been all these catastrophic things going on in the past of the Earth. And we're going to talk about how the catastrophic theory was put down. It was believed and understood, but then it was hushed away because they wanted to have the uniform theory, and the whole purpose of it was to get rid of theistic interpretations of science, meaning that God was involved. Anyway, so scientists are starting to agree that the dinosaurs died by a flood, and yep, read them and weep. The dinosaurs didn't live that long ago, folks. And there's a lot of legends of dinosaurs coexisting with humans, and I'm sure they lived off in the wilderness for the most part. But anyway, let's take a look at some of these quotes. There was this major event where 95% of Earth's marine species disappeared at the end of the Permian period. Some 70% of land species, including plants, insects, and vertebrates, also perished. It's arguably the most single important event in biology, but there's no consensus as to what happened. Okay, so many of them are linking this extinction to boiling seas and saying that it was extremely abrupt, that life vanished quickly on a scale of geologic time, and it takes something catastrophic to do that. So they're calling it the Great Dying, and that it was no ordinary spring flood from one of the streams, but catastrophic inundation. Okay, remember what Genesis said? The floods, the fountains of the deep came open, all of them in one day. Okay, and we're going to be looking at a lot of evidence of those fountains. Anyway, a little more on this. The piles of fossils that we find, they're not chewed by predators, so they weren't sitting around forever. They're oriented from east to west, and so they're all like oriented the same way. And a lot of the bones are snapped in half, and they're large skeletons. So the younglings, they were outrun and they were taken earlier. The adults who could run faster did so and got to higher ground and all this, but eventually they got swept up too. So let's see here. Here's another statement. Yes, basically abnormal disturbance of equilibrium. We're not seeing any conditions like this today. So this is kind of funny. Oh crap, was that today with the Noah's flood? But um, some of them maybe got on there. And anyway, that didn't make it a whole lot longer. So yeah, the scientists are saying the dinosaurs died in a flood, in a flash flood, from flooding, in a flood. So it's getting pretty obvious. The tsunamis and fast-moving water swept away whole herds of animals trying to escape the rising water. Okay, this is one reason why thousands of animals are found in common flood sediment graves. So science begins to catch up with religion on truth. Okay, and this is a quick example here. Look at this house. If you were to drive up and there was no house one day and there was one the next, and this wasn't no prefab house, this is a high quality house, and there it is. Okay, so this is kind of what they're saying is happening here with the fossil record. They're saying that there was basically no fossils, and then boom, there's tons of fossils. Okay, as if all of a sudden there it is, you know. Okay, so they call it the Cambrian explosion, and they're going from lifeless Precambrian rocks to fossil-rich layers of the Cambrian. It was like walking past an empty lot on Tuesday and finding a fully furnished home in the same place on Wednesday. We're going to talk more about fossils a little bit, but suffice to say that most of them are found near the surface, as this was a one-time event. Boy, there's a lot of cool stuff we're going to talk about how sediments from the flood were laid down, and the Grand Canyon was split open through an earthquake, and we don't see fossils except for on the surface, and very rare and no major fossils in the Grand Canyon because this was there wasn't a deposit in a long time in life and a deposit in a long time in life. So we'll get there. So let's compare how modern science says that fossilization happens versus how we would say it happens. And we are hitting on a couple of these fossil things as a review, but I feel like it's really important, and we're going to glaze over some of it to try and build up this flood case. So they say an animal dies, okay, and now they're saying it's more than a little trickle. They're admitting that, but the main thing you're going to find in your books still is that they died, some flooding happened, some mud covered them, and then eventually, poof, they turned into fossils. But they don't say how they could turn into fossils. They say it was like a slow groundwater leaching of silica into the bones. But this doesn't work. The average temperature and pressure of Earth's surface does not contribute to silica saturation much above 6 parts per million in typical groundwater. And remember, the fossils are being found predominantly toward the surface. You go excavate a building site, and boom, there's your fossils. Every now and then you'll get some deep fossils, but those were because surface things fell in to this deep situation called sprouting, and we're going to talk about that later. But anyway, at such a low concentration of silica saturation, the only microscopic quartz crystals could form. So only microscopics, none of these big things. This is not even large enough to cement silt or sand grains into stone. So it just ain't working. The fossilization ain't working, according to their theory. But let's look at this other theory, which was the hypertherm, which is heat, water, pressure, mineralizer. Okay, this is the condition. This is the magic recipe. This is God's signature of the flood, of His judgment on the world. This is, when you see a fossil, that's God's signature of His judgment on the world, and it's this perfect recipe because it's not happening today. You won't find in processed fossils. You look at Mount St. Helens, and okay, if the dinosaurs died from volcanic eruptions or comets or something, then okay, well, let's look at Mount St. Helens. Well, that stuff's not fossilizing, it's just decaying. So obviously the conditions are different. Something was happening back then that's not happening right now. It's a major point. And this is a really neat walkway thing. Oh, you think the flood of Noah was just local? Well, guess what? Anywhere that you find a fossil, the flood was there. And that's a big takeaway for you. And what you'll find out is that a lot of things are fossils that you may not have considered fossils. And we're going to talk about how quartz sand, even just basic sand all around the world, a lot of it was crystallized during the flood. So there's mega flooding on Mars. Why don't we admit that it could happen on Earth if it was from Mars? So on Mars, they don't have all the rain and atmosphere, water, all this that we do here to kind of smooth things out. So it's a little more obvious on Mars. You can see these big boulders from waters passing over. You can see these, let me move this so you can see in the corner, these geyser hydro fountains. This is a image on the left from satellite, on the right a depiction. All these hydro fountains on Mars, and they're geysers. Okay, so again, there's a bunch of stuff on this. How could the water have disappeared so fast? Where did it go? Maybe some was lost for good when it evaporated and rose high in the atmosphere, where radiation split it into atoms that escaped to space. Some of it remains on Mars, frozen at the poles, and much may be hiding underground, possibly in glaciers buried beneath the dust. Again, we're talking Mars here. Perhaps the layers in the surveyor images represent the only record in the erosion landscapes, long gone because the processes that created them no longer operate on Mars. Yeah. Unbelievable amounts of material were moved around in ways that just don't add up. So if you don't have flooding as an explanation for Mars as well, they just don't have a clue what's going on over there. Okay. So the English Channel, they're admitting that was flooding that made that. Major flooding, catastrophic flooding rather than coarse normal erosion. Probably 100 times greater than the average discharge of the Mississippi River. Could have been much larger. That erosion by river or ocean can't account for the underwater valley because it was too wide and has structures characteristic of a major flood. The valley cuts across a large number of rock types, simply ignoring the different layers, he said, explaining that only a rapid, enormous, powerful flood could account for such bedrock scouring features. The Scoblins in Washington, okay? Only in the last 2 decades has the flood hypothesis gained general acceptance. So they're admitting now, yeah, this can't be explained by slow process over time. Something had to happen here. The channeled Scotland emphatically did not form by a continuous progression of processes that were very similar that we observe in action today. And again, here's what I was talking about earlier about uniform theory to take out divine providence and replace it, with to replace catastrophism. They say, as a hypothesis, substantive uniformitarianism evolved as an alternative geological explanation to assumptions of special creations and interferences by divine providence. So this is the deal. When someone wants to just say, oh, God used evolution, I can't stand it 1 minute. Because the whole point of evolution and old Earth, the entire point of those theories is to erase God from the equation. It wasn't godly men who made those equations, and it doesn't add up on so many levels. And they disregard the flood, they disregard human life being placed here instead of cooked up. It's just broken in so many ways. And I did a different lecture on some things against evolution and how there's no solid evidence, and it's basically a state religion. And it's a cult religion. Let's talk about swift erosion on the Colorado Plateau. Basically, these floodwaters, natural dam breaking, canyon erosion. Okay, this could be major erosion. I think a earthquake could have knocked it out too. The Grand Canyon's on a major fault line. There's dozens of faults along by the Grand Canyon. The canyon itself is a major fault. The floodwaters would have formed large continental lakes and natural dams. Eventually, dams were causing rapid erosion over a short period. And as we pointed out earlier, there's no organic layers between these, so obviously they weren't put down over long periods of time. Here's some Mount St. Helens stuff. These trees that were covered in the mud and all that, they're not petrifying. They're just decaying away. There's, millions of years from now, guess what? Millions of years from now, you're not going to have anything to work with. They're gone. They're going fast. And, so you'll find other areas where you do have petrified wood, not from this eruption, because in the circumstances where the petrified wood was made, it's the same with the fossils. It was the hypertherm. Okay, it was the deep, hot pressurized water. So but Mount St. Helens did carve a lot of channels and all this, and the geologists were like, oh my, that happened very fast, because they don't want anything to happen fast. So one of the things is that you'll notice is that it's a big evidence for water-based Earth. With you look at these volcanoes, and what's the main thing coming out of them? Okay, a lot of people don't know there was no lava that came out of Mount St. Helens 1980 eruption. Okay, and look at Mount Pinatubo on the left here. Look at that massive amount of steam coming out of this. So it's mostly water coming out of these things. Okay, and it's not just the snow that's on top of the mountain that's the water. No, that would account for a very small portion of all of the mud flow and water and such. So something we're going to get talking about here is a lot more of these water volcanoes and hydro fountains. Here is an example of crust collapsing, continents submerging. So take a look at this sewer access pipe, and it's concrete cemented in place, whereas the surrounding asphalt is not so much. It's just laid down on the dirt. So it's staying in place while the other stuff's going down. And we're going to talk about how there's mountains that are from that same process, that there was the heated pressurized water coming up from the crust cracks, and it is what made these solidified structures that stayed when things around it eroded, because they were solidified by hypertherm. Here's another example in the top corner: hydro fountains, hydro sand. Here we're seeing these watery slurries of rocks, sand, mud, all getting shot up from the surface of the ground. Now this is all small scale, okay? Think big scale when you're thinking this is nature examples, but flood times, we're talking this over, hundreds of miles. Okay, and big mountains. We talked about that stuff. Okay, two crests. So I'll talk a little bit about this. And that down there is what you see is ocean floor black smoker, where it actually does give us a pretty darn good look at what it would have been similar to at the bottom of the ocean. So you got plenty of pressure, and this is hot water coming out of these things, and it would be we would suggest from faults near the area, and the movement of crust. And there's daily earth tide where the crust is moving all the time, and there's earthquake swarms. It's just everything's moving all the time from the tidal forces pulling on everything, and that's what we go into in the water versus fire lectures. But anyway, so think of these being all over the place, all over the continents as well when they're buried and they got all this activity going on. So the continent crust is 6 times thicker than the ocean crust. The ocean crust is this dark colored stuff. Now think of when God made the earth. Okay, life didn't get placed on the earth till a little later, until after the water and the land was divided and all this. So the continent crust is this often. Now when we say life on earth, it's not just animals, it's the microbes that color things, and we'll talk more about that. But so you got this when the Pangea happened, when it was broken, in the flood event into those different pieces, and they were spreading apart. There was these hypertherm systems of water and sediment that were forming the oceanic crust at that time as the continents pulled apart. And so you'll see that the mostly granite-based continent crust is less colorful than this ocean crust, because of the not having microbes at that phase in the creation. It also helps you kind of get an idea for which things were made during creation versus which things were made during flood. Those are the two major times. And of course, the events that happen at the Lord's return, it'll be another new heaven and new earth. So in other words, it'll be more major changes to the landscape and major changes to the way things are going as we know it. There's some pretty amazing prophecies and promises for the future of the world. Yeah, so the connection between these black smokers and the mafic oceanic crust, Oceanic rocks between the continents are dark basalt for the same reason black smokers emit black sediment, forming dark minerals at the bottom of the ocean today. They're rich in iron, manganese, and other mafic minerals, which come from microbes that live in the hypertherm environment. So for a long time we thought, oh, well, there's no microbes that live deep in the earth because obviously it's just a big oven down there. What's going to survive down there? But we're finding it's a lot of water actually, and it's not just this magma ocean. So you've actually got quite a bit going on of life down there. And we're going to talk about how these different colored deposits of sand and all this that you see in nature, it's from these underground microbes discoloring things and all this. And when it gets shot up, there's that neat deposit that's different from its surrounding area. So let's talk a little about this. I'm going to do real quick on this. Basically, this just shows that is proof that earthquakes do change the temperature in the water, and that's basically all there is to this. But it's of monumental importance when you're talking about how you got the heat needed for fossilization. When that crust is moving, it's heating up that water tremendously. So more could be said, but let's move on. The Grand Canyon, okay, look at all the seismic activity around it. Like I said, the Grand Canyon itself is the big fault line. You've got so it could be a combination of water carving it out and earthquake, because we know there was at least some earthquake, because look what happened here. The one side rim, the north rim is 8,000 feet average, and the south rim is 1,200 feet lower on average. So what mechanism do we know that can drop areas of Earth's crust quickly in its earthquakes? So again, here we have the Grand Canyon, and this is, all the sediment, all those different layers. It's sediment that was ejected up from deep in the earth during the flood time, and it was cemented into this rock, this sandstone, and it was opened up by large earthquakes. And the Grand Canyon is Arizona's most active earthquake area. Dozens of faults lie within and just outside the canyon. So the canyon was not formed by erosion. That's the popular idea, is that, oh, it's a river eroding it over millions of years. No, sir. And we're going to talk about some more evidences there that, again, we're not finding the organic layers. We're not finding the oils and the fossils and all this, because there was nothing going on between when these layers were happening. These layers were deposited rapidly. Okay, let's move on. Okay, we talked about that. Let's move on. So this is basically the Grand Canyon of Hawaii. It's the Waimea Canyon, and the canyon's acknowledged enormous fault and big collapse as part of the island's is anecdotal evidence further confirming the earthquake origin. So, yeah, the two sides are separated by an enormous fault line, which is a large part of the island moving downwards in a big collapse. So this kind of stuff gives evidence to how the Grand Canyon in the U.S. formed as well. Okay, here's something important. When you look at this Lake Powell sandstone, if the Grand Canyon was eroded by a river over time, it would look like this lower half, but it doesn't. It looks like this upper half. This lower half is the half that's smoothed out by flood waters, and this upper half has not had quite the exposure. And so that's telling evidence that no, the Grand Canyon was not just formed slowly over erosion. We have the sharp edges of the canyon. This is indicative of only a few thousand years of erosion, not millions. Okay. Yeah. So basically, when one more point here, when flooding happens, these things can come up out of the ground as well, and from the liquefaction that we'll talk about later. So geyser hydro fountains. We have geysers, like take a look at Yellowstone, and they make this soft geyserite. You have the hot water, but you don't have the pressure. If this was under, miles of water, then you'd have a lot of pressure and you'd get the quartz. Okay, most of Earth's rocks are quartz. Most of Earth's rocks were made in hypertherms. Okay, the creation and the flood. But here you're getting these soft minerals. Okay, another evidence. So these hydro fountains that we're going to be talking about are everywhere, and we're going to be looking and identifying those. So when you have these pillars that are sticking up out of nowhere, these rocks, and you really wonder how the heck that happened. And basically, you ask yourself as well, how did these withstand millions of years of weathering, and why aren't new ones being formed right now? So basically, the light-colored sand erupts. The sand around it solidifies as well, except for the upper portions which get eroded, and there you have it. So underwater flood erosion carried away the loose sediment layers, exposing the hardened column of white sandstone with hard and semi-hardened underlying red sandstone. The lower layers of sand were hardened as hyperthermal waters from faults allowed the cementation and growth of interstitial quartz crystals. So these rock pipes are worldwide, okay? And we say rock pipes because these are hydro fountains. These are where sediment was coming up out of the ground. The hot pressurized water was solidifying them into rock, whereas all the stuff around them was not where the fountain was, and so it was eroded more because it was not turned into a hard rock like this. So, and these aren't forming today because we don't have these temperatures and pressures. So again, that was Monument Valley, Arizona rock pipes. They're called neglected geological anomalies. Here's more of the same. You can see these opening up. If you look closely on some of these, you can even see the sort of a fountain, open fountain area. And so think of all these little fountains here. And there's more to be said, but let's just move on. Here's more of the same, Kodachrome fossil hydro mountains. There's a tiny little person there. These are huge. So this is big fountains, and you can see these. Let's see what we got here. Yeah, more of the same. So this is examples of how sandstone across the entire Colorado Plateau was cemented. Conduits that brought frictionally heated water from below while the earth was being covered with floodwaters. This is formed of sandstone wider than the surrounding rock as well. So you got to take that into account. This wasn't just eroded from a local mountain. Okay, this is an underwater mud fountain. We're going to talk a little about mud fountains. They're all around the world in the bottom of the ocean, and they move around giant boulders. They spit these giant boulders out. Think of the Mount St. Helens. It was basically a mud fountain because what came out of it, it was mud. And, so think of these on a big scale. Going off all around the world, shooting out tons of sediment. Like I said earlier, the sediment we're walking around today on is flood sediment. So here's a couple more mud fountains. Mud volcanism is a worldwide phenomenon, both in the seafloor and on land. So until recent improvements of marine geophysical data acquisition, its significance has not been fully acknowledged. We have mud volcanoes that root several kilometers below the seafloor, even 9 kilometers we've found deep. And there was this big eruption in Indonesia that these mud fountains that, whole buildings were just skirting across the landscape, and it was crazy because these major mud fountains were messing things up big time. We see these different colored deposits coming up from beneath the earth. We see mud fountains with petrified wood. Okay, let's move on here. And like I said, this is a really quick summary of stuff, even though these videos do go a little long sometimes. The book is like 100 times longer than what we're talking about. So if you're not convinced, do yourself a favor and get the book and look into this a little more. The Badlands mud evidence. So the main thing I want to point out here is these are deposits from mud fountain, and the erosion rate is known of 1 inch annually, but we only have know of about 300 feet of eroded sediment. So this accounts for about a 4,000 year ago deposit. And remember, the flood was about 4,500 years ago, so that about matches up. Now, if this was millions of years old, like they say, it's kind of funny because, then you'd have 79 miles of eroded sediment, and that's just bizarre. So, yeah. Here's where there's something that we talked about. I'm going to show you this picture. Multiple eruptions releasing and collecting debris. We call this sprouting. So this is the rare occasion where you get some fossils much deeper than surface. You can get them 1,300 feet deep because it's this explosion that can happen at the same place because, like a volcano can go off more than once, right? Because it's near that fault, it can get triggered multiple times and there can be multiple slips, etc. So here you've got with these diamonds, which are really hard because they're formed really deep under a lot of pressure. But guess what else is down there? Petrified wood. Who knew? So yeah. So if the diamonds were really formed like they say they are in all this pure lava and all this, then how are you going to have wood down there? See, the wood wouldn't stand it. So basically these organic surface materials, wood, fossils, etc., get fallen down in this hole pretty much. Let's move on here. More could be said, but we're gonna move on. Yeah. So they acknowledge that there's surface materials being found 1,500 meters below its original horizon. So this is an explanation of how these surface materials are falling down into this. Fluidization in the formation of kimberlite pipes. Okay, fluidization. They rarely say the word water because that's kind of taboo. Let's go on to the artist palette. So this is just another cool place where we see different sediments coming up, different colors. This would be also there's little to no erosion by these deposits, and eruptions forming these have been dormant since the flood. Okay, and again, when you're seeing these different colors, think deep in the earth, different temperatures, getting sent up to the surface by these hydro fountains. Hydro fountain means water fountain, and it's exposing those different colored things because of all the different breeds of microbes which exist at different temperatures. Okay, let's go on. So many dikes are hydro rock fountains. We're not saying that all dikes are from water. We're saying that a lot of these dramatic ones are. Most geological dikes are of igneous origin, sand, pebbles, smooth, rounded cobbles. These dikes, however, they're saying these are not igneous origin, okay? Primarily of pumice fractions, sand, pebbles, smooth, rounded cobbles. Geologists call this type of dike a clastic dike. Most clastic dikes form when mobile material, typically slurries of sand and rock fragments, intrude from the side or from below. Slurries, huh? Well, you need water to have that slurry of sand and rock fragments. So we're going to talk more about these. Here's some more examples. These dikes are not from melted rock. On the right here, you can see this is what it looks like when you've got that slurry. Also, if this was igneous melted rock, it would have melted the surrounding walls. So it would have been different here. And what are you seeing here? You're seeing these hydro fountains. These fountains where you're getting pushed up this different type of stuff from the deep. It's a different color even. So here's an interesting case. Capitol Reef basalt hydro rock fountain. So you got this big old mountain here, and it's a hydro fountain, and you've got these spewed out boulders, sizable boulders, and they're on the top of the hill, not in the surrounding valleys, and it's not mixed with the rock types that are around it. So this came up from the deep. Okay, geologists long thought the boulders had moved from Boulder Mountain Ice Age glaciers and streams that carried the rocks down the valley. Studies show that the glaciers were small, and the streams lacked the power to move boulders 9 feet or more in diameter, such as those found around Frisha. Many of the boulders are angular in shape, whereas rocks rolled by streams become rounded. Okay, so the glaciers and rivers are not powerful enough to bring all this from somewhere else, and they're not rounded, so they didn't roll along to get here. These were deposited here. Okay, this is called a rock fountain, hydro rock fountain, where all these rocks from deep in the earth are spat out, and you notice the different coloration as well, etc., etc., etc. So we'll be talking some more details, but anyway, like I mentioned earlier, a lot of the sands are made at the time of the flood too. So you've got the heat, the pressure, the water, and they're crystallizing out of solution. Okay, so this massive creations of all this sand crystals, and you've got the silica dissolving into the solution. This can happen underground where it's hot water, or above ground, which means underwater in this case. This is dissolved pre-existing silica from quartz-based rocks, which provided the material required to start crystallization process of silica sediment. Let's take a little deeper look here. Again, remember you're at your 30,000 feet, which is 13.4 psi, 13.4 thousand psi. Your 750 Fahrenheit. Okay, the surface erosion did not form the majority of the sand, silt, and clay sediment. Okay, that's a pretty big claim there, that it wasn't just surface erosion. We're going to point out example after example of how it couldn't have been surface erosion, how there was no supposed mountain of that substance that it could have come from, and no signs of rivers bringing it, etc. There's missing pebble sizes, which means these we didn't erode and get small because there's missing sizes in the pebbles, which means the different pebbles were formed that way rather than eroding in a continuous scale. The majority of all sediments perthromated from a hyperthermal solution. Scientists say in addition to the weathering process, some clay minerals are formed through hydrothermal activity. They're starting to pick up on some of this. Crystallization, okay, in these hydro systems can be promoted by temperature lowering, pressure lowering, or pressure increase. So it's not just a chemical reaction that can trigger precipitation. Okay, let's go on here. Yeah, these are the missing sizes I was telling you about. So these top ones, they formed, the middle ones formed, the bottom ones formed. They weren't one continual scale of erosion here. Okay, so yeah, if all sediments came from erosion, why are these sizes scarce or missing in nature? This is more evidence of the fact of how these things were all made. Okay, and this is important because if you're just thinking, oh, everything eroded slowly, okay, well, how about, things were made in these catastrophic events and in these water flood events. The flood really changed the surface of the earth more than we probably any of us comprehend. So here we have double terminated crystals. These are called floaters. Usually a crystal will form with one side that has like the pyramid shape. But when you have these double terminated, they call them floaters because it's recognized that these formed in suspended in solution. And then when they grew big enough, they fell out of solution because they were, so heavy. But, again, we got these rocks forming in the water. And something that we'll talk about is, the Earth was not a big fireball because it is not a ball of glass. It's a ball of quartz. And the quartz, if it goes up above a certain temperature, it loses its piezoelectricity. So you can't even, you can't have the Earth forming from a melt. It had to be this water creation and this water flood that made these additional rocks. Gotta move on. Okay, more examples of the same. There's no known instances in modern times or recorded history that such crystals are being formed naturally. This is Death Valley sand dune and clay. So there's no white mountains for these piles to have eroded from. They are from underground hydro fountains. Fault lines run through the area evident by lava extrusions showing earthquake friction made fountains erupt, spewing clay and sand onto the surface. Okay, so does this sand look like it came from surrounding mountains? No, sir. Look at that thing. Okay, the Mesquite sand dunes. Look at this zoomed out picture right here in the middle. It's a satellite image. Okay, this is depicting the various mineral compositions. And, these clays, they don't look like they came from the surrounding mountains. Folks, these came from underground. Okay, the hydro fountains in the flood. That's what's creating all this stuff. You're going to start recognizing more and more of this. So again, take a look at these guys. They're not eroded from surrounding mountains. These are big piles of sediment from different temperature microbes. We're going to look at Yellowstone in a minute. It's pretty obvious to see there. There's those different rings of color based on the temperature. In the middle, it's the one temperature because it's closest to the hot water, and as you move out, it's a different color and different color because different microbes thrive at different temperatures. They don't just. It's not just that there's different minerals that happen to be there. It's it's that these microbes are actually creating these elements, which is a big idea as well. Creating that iron in the red sandstone, creating all these things. Let's move on here. This is an example of how erosion happens quickly. Okay, it doesn't take a million years for that to happen. We're getting, evidences. So, erosion of sandstone. Okay, again, think of this. Okay, Monument Valley, Arizona. Think of it as a hydro fountain pipe where the surrounding sediment in the Colorado Plateau comes from these kind of things. Okay, these are the hydro fountains. These are the sources of the surrounding sediment, and they themselves get hardened and preserved as a mark of what happened. And quartz is what cements these sandstones together, but quartz doesn't form unless you have high pressure. And so the surrounding stuff that wasn't as much direct contact. What? Okay, turn the light on for a few minutes. Yeah, so let's see here. The surrounding stuff eroded away. This process is not happening today. Geologists have no clue how this happened. There's many conflicts and disagreements in the petrographic community about practically every aspect of its genesis. Problems of how and when still unresolved. Okay, the silica content of groundwater is very low. They're saying, yeah, the groundwaters, we just don't have enough silica to make this into a quartz, cement it together. It would require 130,000 cubic miles of average groundwater. Yeah, that's totally unrealistic. We can't even fathom that. And anyway, so they're pretty puzzled, but we are not. Again, why is there no fossils in all of this sandstone? Because it was deposited. It was boom, deposit. Okay, deposit, deposit, deposit. Short amount of time. And cementation through hyperthermal conditions in floodwaters. Okay, so yeah, no fossils. Grand Canyon, okay, Colorado Plateau, okay, you got all these fountains spewing up all this sediment. This was not a long time thing, okay, you're missing, if this was one layer, then wait a long time, another, etc., you'd have oil, soil, coal, lava flows, coral reefs, salt. You have all these different deposits across the geological time period, but you don't have it. Same thing with fossils. You'd have all these different reptiles, vertebrates, all these kind of different things, but you just don't have it. Okay, the only fossils that you have are a few on the surface, and maybe some
Dad?
very rare one that gets mixed in. Hey, I need to do this right now. What do you need?
Why do you have grapes in here?
So I can eat them. You take one. Okay, go to bed. Okay, so national. Hey, no, I'm serious. You need to go to bed. Don't be coming in here. Okay, I'm busy. No one has ever found a fossilized reptile skeleton or bone within the Grand Canyon. Fossil footprints were left by more than 20 species of reptiles and amphibians, but no teeth or bones. In this sandstone within the Grand Canyon, strangely enough, no bones have been located. Okay, let's talk granite boulders. These guys, how did they get on mountaintops? There's no evidence of them eroding. There's not the sediments from erosion. And they're carried up here, but not by the glaciers. We talked about earlier how those glaciers and rivers wouldn't have had the power to be carrying these big boys up here, and there's no evidence of the erosion. So these were carried up in water. And you even have some rounding indicative of some rolling here. Okay, arch formations. How did this happen? Where's all the sediment of, if an arch just erodes in nature, you're not going to have um, the you're not going to have you're going to have all this debris, right, underneath, but we don't see the debris. It's gone. Okay, what happened? These things were blasted through with flood waters, and they carried the debris long gone. Okay, the debris is nowhere to be found. We see some minor debris from the times when we know there were some erosion fallings, 91 and '08 and such, but otherwise it's gone. So yeah, we talked about, here's some of a picture of some of the fossils on the roof of the Grand Canyon. And again, Kennecott Mine, they're digging, it's, about a mile deep, a couple miles across. And I worked there for a few years. And anyway, the only place they've found fossils is on the top 70 feet. So why are we finding all these fossils on the top surface? Because the fossilization processes were flood processes, and they happened on a single event. This wasn't a bunch of little floods making fossils. Okay, this was a big flood that made the fossils. Okay, a quote here: "No well-preserved microfossils have yet been demonstrated unequivocally to have lived in a pre-Cambrian Paleosoil. The existence of life on land as back as 3,000 million years thus remains not only reasonable speculation, uh, but also the idea amenable to further testing from the fossil record of soils." So they're not finding these down where they hoped. Okay, let's go on. So this is what the Bingham Canyon mine looked like before they mined it. And what you'll notice is these ore bodies are vertical deposits. These are fountains of, again, hydro fountains making the ores and the vertical condition. Now, what about the horizontal ores? Okay, you drive into Price, Utah, you see this just amazing different layers here. These are the deposits from the fountains. Okay, getting laid down in layers, like the Grand Canyon. Okay, rivers, they say, oh, rivers, depositing sediment. No, there's these sharp edges and boundaries. This isn't how the rivers work. Yeah. Here we have sediment laid down which came from the fountains. So another very interesting evidence that the flood sediment was deposited around 4,500 years ago, and that there's no organic layers in those flood sediments, is the topsoil is about 9 inches, and they're saying it probably took, about 4,500 years for that topsoil layer to form. And okay, yeah, that's when that's from the flood to now is when that organic top layer was forming, because that's the sediment was all laid down in the flood, and then we've been having our organic party on the top of there for the last 4,500 years. But there's no evidence of these organic layers beneath that, because this was all flood sediment. Okay, we talked about that a little bit. Let's go on. Okay, again, no organic layers in the Grand Canyon either. Okay, let's talk about plains. So look at this big giant rock, Ayers Rock, Australia. This is a big hydro rock mountain, and the surrounding plains are from sediment that came up out of the rock. We're talking big time, lots of sediment, and it made these flat plains. Now, how do you get flat? Okay, scientists are really puzzled on this. Why is it flat, 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 flat for so long? It's because in a uh, sediment coming out and water, it flattens it all out, and it lands out in this flat way. Okay, so the scientists say this is a remarkable thing, that plains of great perfection are ever made, but they are real, and that it remains a mystery to them. It is even more difficult to make a planation surface if the land is rising tectonically, yet the planation surfaces are there. So they're like, why is there this thing? And then, the plain. So they're not putting two and two together, that the one ejected the other and so forth. Yeah. Let's move on. So I'm just going to move on. And I think we're nearing the end here. So alluvial fan, hydrofountain. Okay, so you've got this Death Valley alluvial fan, major alluvial fan. We've got some sediments coming up in the lighter color there, you can see, uh, which are recent, but we haven't had an event where it was so big, so much water to push out things as far as this massive fan. And you see over here on the right, this Mount St. Helens, this stuff came out in a matter of minutes. This carved channel with a little bit of rocks, that's what happens when there was that small amount of water with the Mount St. Helens mud fountain. But over here in the Death Valley alluvial fan, this is a lot more water. We've never seen anything to this scale. We've never seen alluvial fans to this scale being made, okay, because they're not being made right now. It was a flood event. Okay, here's a more open hydro fountains. Look at that. You can see the hydro fountain opening there. These are big hydro fountains, and they're solidified, and they're these things that stick up in nature, and they're puzzle to everyone until you know the ways of the Lord that this is happening. The surrounding plain has no deep valleys or riverbeds, and the sediment around this mountain didn't erode over a long period. No deep valleys exist for the particles to leave. Note the large open pipe shapes. They claim these are normal volcano remnants. The differences, though, include there's no melt, no flow, no erosion exposure, no deep time, and the colored microbe clay is still there. That should have washed away a long time ago if it was as old as they say it is. Okay, liquefaction. This is a really fun part. So, you're driving down the road one day, and oh no, the road is now basically a liquid, and your car falls into it. So this is what we're talking about with liquefaction. We're talking about, okay, Wikipedia definition here. In geology, soil liquefaction refers to the process by which water saturated, unconsolidated sediments are transformed into a substance that acts like a liquid, often in an earthquake. Okay? Notice that it's often in an earthquake as well. So I'm going to move over here and show you this picture down at the bottom. Colorado Plateau liquefaction. Look at all this different colored sediment here. The Great Salt Lake, the Salt Flats, the White Sands National Monument down there, and all this red coloration here. What mountains did this red sand erode from? Well, those mountains don't exist because they didn't come from mountains. These came from under the earth. They're discolored by the microbes. So you've got different witnesses of different events that have been happening. New Madrid earthquakes, okay, reported not only intense ground shaking. The survivors reported not only intense ground shaking lava movement, as would be expected during an earthquake, but also unfamiliar phenomena of water and sand spouting up through fissures or cracks in the Earth's surface. Water and sand spouting up, huh? Okay. So again, where's the sediment coming from? Big geological event of the flood. This large earthquake initiated in India 2001, liquefaction triggering hydro fountains that spouted sand over an area greater than 15,000 square kilometers, or 9,000 square miles in India. Okay, so here's just a couple more things of this happening. Here's a diagram on the left of what it could look like with this earthquake fracture, local generation of lava, and the slippage here. Here's the another evidence here of catastrophe from not a volcano of lava, but of water and rock. Near Kobe, there is no active volcano, and heat flow studies revealed no significant lateral changes in temperature before the earthquake. Therefore, we suggest that the anomaly at the Kobe Hypocenter is not related to a magma reservoir, but rather to the presence of fluids in the crust. And notice, again, they won't say water, but at least they said fluids. And they said not magma reservoir. So let's move on. Okay, here we are again. Again, you'll see these whole buildings just skirting around and everything getting changed, all this by these hydro rocks. Okay, the Chai Chai earthquake, 1999. The ground seemed to explode as huge boulders were flung into the air. Okay, I really like this one of the mountain liquefaction again here. Again, remember our sewer access pipe? Well, take a look and look at these things standing around here. Now, you can see this, the surrounding plains went down and these went up. Now you see this low erosion top part is that came up, and then the bottom part where there's a little more erosion is where water subsided and sediment subsided around it and whatnot, and some residual flood waters maybe crashing through doing some erosion. But again, and then here you've got this sand fountain that's spewing up all this sand over here. So think of these on a big scale, and that's what's happening here. This is how it's working. Some firmly attached things go up and the landscape goes down. So mountain liquefaction evidence, some more of it. Soft green clay deposits. Those aren't millions of years old. They're from liquefaction, not eroded. Yeah, gray hydrofountain deposits confirm this mountain was made not by erosion. And suffice to say, let's go on here. Okay, so here's more of these great plains. How are these plains happening? And then boom, it splits open in the middle, right, from these earthquakes. And so what we have to recognize is that this flood, it was a universal worldwide flood. It impacted the entire surface of the earth. And again, there's you can see here, where's the eroded red sand here, you know, sediment thousands of feet deep showing no erosional patterns. The entire valley, okay, here we are in Montana. The entire valley was covered by fast-moving water to deposit the cobblestones. Even Mount St. Helens eruption didn't sort stones like that. It's because it didn't have nearly as much water. Okay, let's go on. Here's more rocks precipitating from water. It's this idea: you get your seed crystal, put it in the supersaturated solution, and you're precipitating out. And when you got this high pressure, you're getting these quartz crystals. The technologists make rocks in water. Okay, guess what? When they want to make granite, they have to make it water-based, not melt-based. When they want to make, you know, quartz for watches and all this, there's a shortage in World War II. They want to make all these quartz crystals for the watches and for the piezoelectric oscillations, and they had to make it in water because that's how quartz is made. So let's see here, James Hutton. Yep. Yeah. So James Hutton walks on scene and he says, "Hey guys, the Earth wasn't water-based. It's because look, I put this rock. If this rock was made in water, I'll put it back in the water and see if it dissolves. If it was made in the water, it should dissolve in the water. But the water that was made in is not your normal water. It's not the normal temperature. It's not the normal pressure. So he was way off. Yeah. Okay, and as you see, the whole rock cycle needs reevaluating because magma is the heart of the rock cycle, and it's got to go. Crystalline structures are made with water, not a melt. Here he's making these crystals. He makes geodes. He makes petrified wood fossils. He makes, all these different things because he knows the recipe for the amount of heat and pressure and, of course, the water aqueous environment. So that's the mark of a true scientist. These aren't just philosophies. These are actually boots on the ground showing it. And say your prayers for Dean that he can get volume 3 out where he'll throw down more on that kind of topic. The final installment of the Universal Model series. Yeah, so water is how God created the earth. The quartz rocks came from water, and this is something we talked about more in the last lecture of the water versus fire, so check that out. Water is the primordial matter in the universe. All the matter originated from water, and the crystalline minerals are from water, and all organisms are born in water. Let's race to the finish here. So where's the basalt, okay? The basalt origin, okay? Look at all these historical lava flows. Where's the basalt? Well, it's not coming from these lava flows. Okay, so let's take a look a little closer here. Here we have these rocks from lava on the surface. They've got this rough texture. They've got all these holes from the gas escaping. These were a low pressure rock formation. Now, let's take a look here at some basalt. This is a fine-grained substance, and when you try to melt it to see if it came from a melt, it totally messes it up, turns it into a glass. This was not from a melt. It has crystalline quartz and no vesicles, and is fine-grained, which is proof of it being made in pressurized water. Here is obsidian. Okay, same kind of story, a little different composition, of course. And they're admitting the initial activity was submarine, but later the volcano gradually built up to sea level. Again, you melt it, and you'll see it wasn't made in a melt. It wasn't formed in the air. It was formed in alkaline water. Obsidian flows are made at the bottom of an ocean hypotherm as well, and they have no vesicles, which is evidence of their being under high pressure, namely under 3,000 meters of water. Let's look at a little picture here, a diagram. We're also going to talk about how the basalt flows under this pressure will form these columns. And again, we're at the depth here that there's no vesicles. So the fact that these are sandwiched between ocean sediments, basalt essentially proves the submarine volcanism took place. And these rocks won't dissolve in water, but they weren't created in normal water, as we talked about. So here's this potato starch. You mix with water and dump water on the thing, and it's going to form in these column shapes. And we see this underwater from the Puna Ridge, Hawaii. The researchers are beginning to recognize the direct evidence of aqueous column formation, which shows the importance of water and high pressure. So let's take a look here. Devil's Tower. Guess what? Aqueous formation. Okay. We can prove that it's a hydrocrater mountain origin. Okay. So we're going to need to prove, well, a couple things to demonstrate that. Okay, so let's do that. The tower intrusion itself is evidence of a diatreme, so there's the first feature. And the Devil's Tower is near the middle of a collapsed dome. And the 3 faults were observed in the area of the National Monument. And this is along the Belfort River. So you've got the water source, you've got the fault heat source, you've got the shape of the dome and so forth. So again, here's more of these columns. This is Paul Bunyan's wood pile. We hiked up that a couple months ago, and it's really cool because they're rocks shaped like these logs. You know, it's called the wood pile. It's not petrified wood, but it's this. It was this aqueous pressurized lava that made these. And here you've got the Devil's Post pile. Okay, pretty amazing. And Giant's Causeway, Ireland. All these hexagonal and columnar things going on here. Lava does not cool to form basalt columns, folks. It is only in pressurized aqueous situation. So here's some more of these. Okay, so a little bit here, some of the black smokers and white smokers. Okay, releasing alkaline and basic fluids on the surface floor. And again, the bacteria, microbes. We used to think that there's inside the deep in the earth is very hostile, no life, but now we're seeing, oh, well, it's a bunch of water down there, so, and there's tons, endobiosphere it's called, the life beneath the sun, beneath the crust, and it's contributing to these colors of these deposits and everything. Yeah, so the colors, look at this, the iron, the microbes made the iron that's in these Havasupai, Grand Canyon walls here. Okay, look at these hot springs. This is really cool. So we read that you can tell the approximate temperature of a stream by the color of its cyanobacteria. If there are no cyanobacteria, the temperature must be greater than 167 Fahrenheit. If the bacteria mat is bright yellow, the temperature is around 160 Fahrenheit. Brilliant orange, it's about 130 Fahrenheit. And pure green shows up around 120 Fahrenheit and below. Okay, these microbes produce iron and the other elements, and the different microbe species thrive in different temperatures. And there was a whole lot of this going on when it was high temperatures during the flood. Okay, again, these white sands national monument. Why is it white? Where are the rivers transporting the gypsum sand from the mountains? Nope, these were not deposited from a river. This was an underground ejection. Okay, and rain over millions of years would have dissolved the gypsum sand crystals. Why do they still exist? Because this wasn't millions of years. It was just 4,500 years ago, the flood. And we are really close to the end here. So carbonic the carbonic acid cave stuff. Okay, so the water is actually alkaline, not acidic, and the caves are growing, not eroding. What happened is the water blasted these caves. That's how we got these caves carved, is the water flowing through these aquifers and all this. And so aquifers running through freshly laid down flood sediment form these caves. The flood hypertherms hardened the layers, preserving the voids as rocks. The formations grew by microbes, not redeposit of dissolved carbonate. And a fun note here is that it's cold when you get deep in the earth, not hotter. So more anti-magma stuff. Okay. All right. So in review, the flood of Noah was worldwide and covered all the earth, including the mountains. Fossils, including quartz, sand, dinosaurs, etc., all witness of the flood and were a one-time event near surface, not occurring today. A comet induced the flood via slowing the Earth's spin and sinking continents into water from beneath. The water, mud, and rock fountains spewed materials dramatically changing the landscape, creating vast plains. Hardened hydro fountains all around the world attest to this. Quartz, which is most rocks, were made in hot, pressurized water, as supplied by the faults and earthquakes and the depth of the floodwaters. So that's it. So go ahead, go to universalmodel.com, get the book, and special thanks to Dean Sessions. He did all the work. I'm just talking about it. And you can get this PowerPoint and watch similar presentations, etc., and other little summary booklets on All that's for free at richardsonstudies.com. So check that out. Thanks so much. My name is Nate Richardson, and until next time.